Hello, today I will talk about Cartesian product. I will solve some examples and questions. Before getting started, we must know what is ordered pair. The definition of it is a pair of elements A, B having that A, B and is equal to U, V if and only if A equals to U and B equals to V. What does this definition mean? It actually says that this ordered pair wouldn't be equal to this ordered pair because the order would change and the results would change. Therefore, those pairs are named as ordered pairs. To understand it, to clarify, let's solve this example together. Now we will try to find the points according to the ordered pairs. 2, 5. By the way, this 2, the first component in an ordered pair would refer to the x-axis, and the second component would refer to the y-axis. Now, let's do it. 2. It would be probably like something here, 2 and 3. Now we will overlap them. Something like this. 1 and 5. X is 1 and y is 5. It would be like this. And then -1 to 4. -1 to 4. Something like this, I guess. And then 3 to 2. Yes, 3 to 2. We did this. We solved this example to show that if the order changes, the results would change, because in an ordered pair, the order is important. Like, as you can see, the components are the same. They have the same number, 2 and 3. However, the order is different, so the locations would change. Okay, before getting started, before knowing what is Cartesian product, let's talk about a short history of it. The Cartesian product is named after René Descartes, who was a French mathematician and who contributed very important formulas to analytical geometry and gave a rise to it, and contributed important formulas and various things, such as one of them is Cartesian product, right? We use it to find locations, and we use while coding, actually, such as Java and Python coding programs. We use it. Okay, let's start to our main topic, the Cartesian product. Definition of it is the Cartesian product of two sets A and B, denoted by A times B, is the set of all possible ordered pairs A, B. This is why ordered pair is important for Cartesian product, because we write them as ordered pairs. This is the notation. This is the notion of it. To understand it, let's solve a simple example. X times, given X, set X, these are the sets, and the elements of set X is 1 and 2, and for Y, the set Y, the elements of set Y is 0 and 1. These are, to show it, we use these fancy brackets. Okay, X, to understand, let's visualize it. X times Y. X, the elements of X are 1 and 2, right? We see it's obvious. And for Y, we would say 0 to 1, right? And we will try to find all possible orders. All possible ordered pairs, sorry. We will match 1 to 0, right? The first ordered pair would be like 1 to 0. 1 to 0. And then 1 to 1, right? We are trying to find all possibilities. 1 to 1. And then Now 1 is done. We will continue with the second component of the set X, which is 2. 2 to 0. 2 to 0 and 2 to 1. 2 to 1. These are the all possible orders, all possible ordered pairs, as we just wrote here. To show that if the order changes, if the multiplicational order changes, the results would flip. Let's justify it. Again, let's write the elements of it. Let's try to match it. 0 to 1 is the first pair, right? We should start from Y, from left side to right side. 0 to 1, 0 to 2, 0 to 2, and then 1 to 1, 1 to 1, and then 1 to 2, right? 1 to 2. Okay, these are the all possible ordered pairs. I am not sure whether you see that, but as you can see, all the results are the flipped. Like the first component and the second component are just vice versa. They are flipped. Therefore, they are not same. They are not same. Let's solve some examples quickly. A times C, Cartesian product of A and C, would be, okay, now as we just said, first components of ordered pairs would be from the first set that multiplies with another, which is A, right? The first set is A in here, at here. A, so the components would be first from the set A. B, one of them is B. B to B, right? And then B to 5, another possibility. And then now B is done. There are no other components in C. And then next we will continue with 2. 2 to B, 2 to 5. Okay, this is the listed form of all ordered pairs. And then, because Cartesian product is in the set theory, we must know intersection, union, those type of terms. Therefore, let's do it. What is intersection? Very simply, briefly, intersection means the same element. What are the same elements? For set A and B. Set A and B, we see that it's just B. We would just write then B. That's it. Very simple. And we will come to this after a while. Let's continue from here. Na, number of elements. Okay. N. This means number of elements in the set A, which is, as you can see, 2. 2 elements. And for this, it's like it asks for the number of elements multiplication by set A and B. We can write, instead of writing like this, why don't we write like this, right? Number of elements in set A and the multiplication of number of elements in the set B. As we just wrote here, it's 2 times and 2. We would get 4. Okay, now about this one. Now let's write it like B intersection with C. B intersection with C is, what is it? 3 elements. A, B, 5, right? Because they have the same element, we only write the same elements for one time. For the set A has B and 2. Let's find the possible ordered pairs. B, okay, we will now match it. B and A. B and B, B and 5. B is done. Now 2. 2 and A, 2 and B, 2. Because we don't have space, I have to continue from here. 2 to 5. These are the possible ordered pairs. And now it asks for the number of this Cartesian product. It is, as you can see, 1, 2, 3, 4, 5, 6. It is 6. Let's solve two questions to understand, comprehend it better. Let's start with this one. X and Y are two sets, and X is 10, and X and Y times X is 19. Find number of elements in the set Y. Okay. Instead of writing like this, why don't we make it easier, like writing like this? And it says that this equals to 90. So as it given above, X is 10, we would divide both sides with 10 to find number of elements in the set Y. So 9 equals to number of elements in the set Y. Set Y has 9 elements. Okay, for this question, it's a nice question actually. As we just mentioned before starting, let's write like this. Okay, first components of all ordered pairs would belong to the first set in the multiplication, right? So we would see what are them, 1 and 2 for the set A. For the first set, all the first components belong to the first set, 1 and 2. We don't write again 1 because it's nonsense, like they are same. And for the set B, A, B, C, they all repeat. Therefore A, B, C only we would write A, B, C. It asks for the union, and then we will find the number of elements. Okay, union of it is A union B is 1, 2, A, B, C. We would write all the elements together, and then number of it is, as you can see, 5. The answer is 5. Thank you for listening me. Today I shared Cartesian product. I solved some examples and questions. Thank you for listening.